Sweet. Hi, good day. My name is Mandela Patrick. A recent grad at Oxford, and today I'll be presenting this presentation called the PhD Playbook, the lessons learned during my PhD experience that hopefully you can apply. So a little bit about me. I was born and I grew up in a small Caribbean island of Trinidad and Tobago. Spent my first 18 years there. And then was fortunate enough to do my undergraduate studies at Harvard University, where I graduated with a Bachelor's of Arts and Honors in 2018. I then won a Rhodes Scholarship to pursue my PhD at the University of Oxford. There I spent 3 wonderful years, and I graduated in August with a PhD from the BGG group. A lot of my research interests surround multimodal and self-supervised learning, and I'm now currently a machine learning scientist at Pinata Farms, where we're trying to essentially enable people to communicate using video. So what is a PhD playbook? So this is the set of strategies that made me successful during my PhD, and hopefully that can be helpful to others. The playbook has been divided into the following sections. 1, it takes a village. The importance of the people in your PhD journey. 2, the paper checklist, which is some of the tips that I found very helpful for a competitive submission. And then 3, what's next? Tips on what to do next after completing your PhD. So it takes a village. So I always like to ask this question because I get a lot of diverse answers. So what's the most important section of my thesis? So I wrote maybe 130, 140 pages. And for me, the most important section is actually only 2 pages, and it's the acknowledgements section. And the point I want to hammer home here is that the people that you surround yourself with, the supervisors and your postdocs, the collaborators, people who you look to as mentors and sponsors, friends and family make a huge impact on your PhD experience. And honestly, frankly, outside of your family, you have quite a bit of control over a lot of these other, in the sense that you have quite a bit of control over who you surround yourself with during your PhD experience. And so a lot of this presentation is trying to give advice on why these sort of relationships are important, and maybe how to sort of maximize or establish these relationships. So supervisors. So when you're applying for a PhD, in the US, you usually apply to a PhD program. Let's say computer science, electrical engineering, or statistics. You then do a year or 2 of maybe a master's degree where you do classes, maybe a master's research project, and then you decide on a particular supervisor to work with over the next 3 to 4 or 5 years. In the UK, it's a little bit different. You actually apply directly to a supervisor. And so in both cases, your supervisor is actually probably the most important relationship you have during your PhD. And I always stress a lot of my friends who reach out to me about advice about applying to PhD programs, really talk to past and current students. Get a really sort of nuanced perspective on what it is like being a PhD student with the supervisor. Figuring out, you want to understand what is that supervisor style. Is that person hands-off, or is the person hands-on, or is he or she somewhere in the middle? Does the supervisor think very long-term about research? So essentially is only really willing to sort of let you publish when you've made something very substantial contribution, or is sort of willing to sort of basically push for every single conference? I think it honestly depends on what you enjoy, or like how do you want to make your own PhD experience. For me personally, I think I wanted a balance of not too hands-off, but somewhere in the middle. And I thought I found that really well with my supervisors. where I got the space to explore research interests and explore what gets me excited, but also had this sort of help and advice from my supervisors who knew the field really well. Another advice I always give is does your supervisor have overlapping research interests? And is your supervisor willing to, if he or she is not familiar with your area of research or what you're passionate about, is he or she willing to sort of help you along that journey or go on that journey along with you? And so I think having a supervisor who is either knowledgeable about your research area or who's willing to essentially become knowledgeable in your research area is, I think, a huge benefit in how successful your PhD is, because he or she can then offer you point you to the right sort of related works, point you to the right data sets, the right conferences. And so that sort of nuanced perspective is extremely valuable when you have a supervisor who shares very similar research interests to you. And so for me, these are the two most important things. What is the supervisor's research style? Hands-on, hands-off, long-term versus short-term, and then what are their research interests? And really talk to current and past students to get that perspective. Collaborators. So collaborators was probably one of the most impactful relationships and impactful parts of my PhD. And what I try to emphasize to people is to collaborate, not compete. And like, if you look at some of the top papers, a lot of them aren't written by single authors, even two authors. A lot of them requires maybe quite a few people to really make a huge impact. And I put up a picture of the really popular GPT-3 work from OpenAI, where I didn't know how much authors are on that paper. It's probably 20 some, probably like close to 20. And that just shows just like the power of collaboration in sort of making really groundbreaking research. And collaboration has a few benefits. One is that you get to sort of bounce ideas off of other people. I think it's quite easy to get to sort of like stay in your bubble and get and sort of able to convince yourself that this direction of research makes sense. But having someone else to sort of bounce ideas from, get a different perspective, I think is super important to essentially iterate quickly and push research forward in the right direction. Also, stuff like peer programming, like being able to detect bugs in your code, like just having that extra set of eyes, that extra perspective, I think is so valuable, because you end up spending so much time on these small issues and going down the wrong path. And it's honestly just talking to someone else who's knowledgeable about the area, who's also interested in, who's also working with you on this project, makes a huge difference. And for me, like, I've seen it honestly, both in my research lab and in other research labs as well. The students who I think struggle the most, or who have sort of toughest time, are those who sort of really just work by themselves on a particular project, and they're not collaborating with either research students in the lab or outside of the lab. And I've seen it personally, and like, I've heard the stories. And so this is like probably like my biggest advice to everyone is find at least one other person to really collaborate with. And I think the important thing with collaborations though is that there is this issue of like authorship. Like, you want to own your PhD, you want to own your research, and I think you can have that experience by essentially sharing and rotating the first authorship. And so if you did one paper as the first author, the next submission can be the person that you're collaborating with. And then sort of like having both of you as dual first authors and sharing that authorship, I think is just such a, honestly, really good way to do, I think, very tight collaboration with another research PhD student. And I've seen that work really well with a few of my friends in my lab, and they've published at some of the best conferences. They have honestly a ton of papers during their PhD, and you just produce just better research. And then my last piece of advice for collaboration is let everyone play to their strengths. Some might be better at, say, the more mathsy part of research. Some might have a better programming background. Some might be a very good writer. And so I think recognizing everyone's strengths and sort of letting everyone play to their strengths, I think is super beneficial in collaborations. And I think there's this perspective that like some parts are more valuable than others. Like honestly, at the end of the day, like this is a research project. A research project has multiple parts, whether that's the paper writing itself, whether that's the formulation of the algorithm, whether that's the actual coding and running experiments, whether that's the running the benchmarks, and everyone has a part to play, and every part adds to that final product and that final research project. So I think this idea of some parts are more important than others are very harmful and very toxic for collaborations. And I think emphasizing that everyone is playing a very important role, no matter what their role is super important. Mentors. So mentors are those you go to for advice. And the point I try to stress is that you don't have to know all the answers. I think as PhD students, as most of us are probably type A, used to being top of our class or pretty much being an expert in our area. Like, it's okay not to know. It's okay to ask for advice. And I think that's something that I've been really good at, is that I'm not afraid to ask questions. I'm not afraid to be vulnerable, and being open to getting a different perspective or getting advice from others, I think is another big advice I have for everyone. And I think what's important is sort of establishing your sort of personal board of directors. And so basically a group of people, maybe with like different skill sets, different experience, that you can go to for advice, whether that's about internship opportunities, research directions, post-grad opportunities, just life in general, mental health. And I think that's like super important. And I would encourage people to sort of try to establish these relationships organically. Don't try to force it. But something to keep in mind is sort of really having those group of people around you, your personal board of directors, to go to for advice when you're sort of considering essentially a lot of these questions that you may be going through. So sponsors are quite similar to mentors, but I think it's a little bit different. And the main difference is that sponsors are those in senior positions who can advocate for you. They can do stuff. And I've been fortunate enough to have some really good sponsors throughout my PhD journey. Two in particular, Florian and Jeffrey, who were my managers at Facebook. They played a big role in sort of ensuring that I was connected to the right opportunities, connected on the right projects, and they advocated for me throughout my time at Facebook. And I tried to encourage a lot of my PhD students to establish such relationships during, say, internships, externships, research collaborations. Like sponsors, they can open up a lot of doors for you. They look out for your best interests, and they've been in your shoes before. They understand what you're going through. And so I encourage everyone to find those sponsors, try to establish those relationships during internships. And again, here, try to make it organic. Don't try to force it, but keep that in mind as well when you're doing your internships at these companies. And then friends and family, like a PhD is a long and difficult journey. So maybe 3, 4, 5, 6 years, and family and friends play such a critical role in helping getting you through. They support you through the tough times. They celebrate with you during the good times. And yeah, like they're always there for you. Like when your losses, like when your loss function are giving you nans, when you get that new acceptance, they're always there through the highs and the lows. And like, yeah, definitely continue to nourish those relationships, family, friends. And so yeah, that's another big piece for me, was that I always felt that, and like it gives you a bit of perspective as well. Like you have like your family, just imagine like your mom or your dad or your brother or your sister, like that smile on their face after you're finished and get a doctorate. Like they give you that, I think, that perspective, that sort of drive, because yeah, they're rooting for you, they're in your corner. And so yes, to re-emphasize, it honestly takes a village. Like I may now be Dr. Patrick, but it's like my title, my success is definitely not solely because of what I've done and what I've been able to accomplish. It's been honestly fundamentally by those people that I've been fortunate enough to surround myself with, those supervisors, those sponsors, those mentors, those collaborators. And yeah, and the advice I sort of push everyone is to really build a village for you. Build that village who would take you forward and really make you successful during your PhD. The other part of this playbook I want to touch on is sort of the paper checklist. And these are some of tips that I leveraged during my PhD that I found it to be helpful for a competitive submission. I was fortunate enough to have a very good publication record during my PhD, and it was interesting. I think honestly at the beginning of my PhD, I'd never written like a top publication paper before, but by the end, I sort of honestly kind of, and like when you submit a paper to a conference, you're unsure whether it's gonna get in or not. And I think at the end of my PhD experience, I had a much better sort of intuition of feel of like what is a strong paper and when I think a paper is going to get in versus say another. And I think you started recognizing these patterns, and some of these patterns I try to sort of distill here in this presentation. So I have a checklist overview, and it's I call it the 6 C's. And the 6 C's are, I think, probably the highest leverage stuff that you can do to have a strong paper submission. One is a catchy title. It makes a huge difference. It's something people don't, I think, pay enough attention on, but it's honestly the first thing that someone sees or knows about your paper, whether that's on archive, whether that's on in what reviewers see. Like when reviewers get their list of papers, they literally get a list of paper IDs and paper titles. So paper, like a title is honestly probably the first entry point into a lot of people's minds. And so making a title catchy and memorable is so important. The other C is a clear splash figure. And after the title, you have your abstract, you have your intro, but most humans are very visual persons. The thing that catches their eye first is honestly the splash figure. And making it so that it's very clear, it's very memorable, and it communicates your contributions clearly is so important. And it's probably the other biggest part is having a clear splash figure. 3 is to cite thoroughly. This has made a huge difference, I think, in a lot of my papers. And it's a very simple but high impact thing that you can do. The 4th is contribution. So what are you contributing to the literature? And in my experience, having more than one contributions always helps. This was something that my supervisor always stressed to me, is that we need to have at least 2 or 3 technical contributions before we submit this paper. And I've seen it, and honestly, each of those papers that has had 2 or 3 contributions have all gotten in, and at honestly the biggest conferences. The 5th C is compared to a baseline. And what that means is that be clear what your baseline is, and then show how your contributions improve upon that baseline. And that's honestly done through ablations, but being very clear on what your baseline is. Like, this is what we're trying to improve on, and these are the ways that we're improving on this baseline, and this is the impact it's having. And then lastly, compare to the state of the art. If you can beat or be competitive to the state of the art, that always helps. And I must caution, a lot of this advice is specific to computer vision conferences or computer vision style papers, but some of these are quite transferable across domains and the literature. So to go a little bit deeper, as I said, catchy title. It gives an idea about a topic, but leaves the reader wanting to learn more. And so 2 papers that I've been fortunate enough to get into NeurIPS, and these are the 2 papers I'm going to be using as sort of templates for a lot of the points I'm trying to make. was SOTA, where we try to label unlabeled videos from scratch with multimodal self-supervision, and then keeping your eye on the ball, which is basically a new attention mechanism that we came up with for video transformers, which is oral this year at NeurIPS. And I may be biased, but I think both titles are quite memorable. The first one sort of leaves you like how are they doing? Like this is cool. Like how are they doing this? How can we automatically label videos without any sort of domain knowledge? So essentially from scratch. And so I think it creates that curiosity for a reviewer or reader to want to learn more, like how are they doing this? And then similarly, on the trajectory attention on paper, the phrase keeping your eye on the ball sort of paints a very vivid picture of what this paper is about, sort of that we want to essentially model trajectories, and particularly with video transformers. And I think both papers both had very eye-catching titles to get readers excited about it from the beginning. The next is the splash figure. And this has to capture the method or the intuition of the approach very clearly. And so on the left, similarly, we wanted to show, like, even though we're doing this cool automatic pseudo labeling of videos, on a high level, what we're doing is a very simple or elegant approach. We essentially have two encoders. We have some sort of training and labeling step, and it communicates that high level intuition very clearly. Similarly, on the right, what we wanted to communicate is essentially we want our attention to follow the implicit trajectory of different objects moving throughout the video. And in one simple but compact figure, we were able to capture what are we trying to accomplish with this sort of attention mechanism. We also have the colors are also very bright, it's very popping. And so it captures your attention, I think, very easily at the get-go. Related works. And as I mentioned in the checklist, cite thoroughly, cite as many relevant works as possible. To the extent where one of my supervisors made this very funny comment, is that one of our papers, we had maybe 100 and something, like 110 citations around there. And he joked about whether this paper that we were submitting, whether we were going to get as much citations, as many as the paper that we were citing. And that just goes to show the extent to which I tried to cite as thoroughly as possible. To be honest, and it's a little bit sad to say, but I think it ends up being true, is that if you have a reviewer who doesn't see their work being cited, it affects how they perceive your work. And to essentially mitigate against that is to cite as many works as possible. And there are a lot of very great resources to help you with this endeavor. There's this website that I love called Connected Papers, which shows you essentially the graphical relationships between different papers and how much they contribute to each other. And then some more standard ones, such as Semantic Scholar and Papers with Code. So the method. Have found that papers which have very clear and simple language, which are very easy to follow, are better, or sort of, for me, get accepted more than those which have more convoluted language and a lot more difficult to follow. Because if you think about it, a reviewer is spending limited amount of time on your paper, maybe a couple hours. And if they cannot get the gist of what you're communicating easily or quickly, they're gonna lose interest. They're gonna be what is the point of this work? And I think that having a clear and simple language that is very easy to follow is so important. And I think both these works, SOTA and Trajectory Attention, did a very good job of really making the language super easy to follow in the method and communicating very clearly what we're trying to accomplish and why. And to a point I was making earlier, having more than one technical contribution is ideal. So for both these NeurIPS papers, for the syllabi, we showed how we can improve clustering so that it doesn't collapse, that it can work with any clustering distribution, whether that's uniform, Gaussian, and how we can do this in a multimodal context. So essentially, and similarly with the trajectory attention, we showed how we can improve upon other attention mechanisms of video transformers, particularly divided space-time attention, as well as the vanilla space-time attention, and then how we can approximate this using a new approximation mechanism so that it can be used on longer videos. And so in both cases, we have more than one, ideally 2 to 3 technical contributions, and it basically adds a lot of meat to your paper and sort of makes it a very comprehensive contribution. And so, yeah, 2 or 3 contributions. This has been something that my supervisor always stresses, is that you have to have 2 or 3 technical contributions to have a competitive paper. And both papers got in, so for the most part, I think it's been working for me. On the results part, extensive ablations. I think this for me is the most important thing to do in your results section, is to show how what you're contributing or what you're proposing improves upon a baseline. And in this case, you show it through ablations, where you show how each component of your new model or new system or new algorithm improves a baseline and shows improvements on sort of the standard data sets that people care about. And I encourage PhD students to really anticipate any ablation requests that may come from reviewers, whether that's on a specific data set, specific hyperparameter, and either add that to the main paper or the appendix. Think like a reviewer, like what would the reviewer be uncertain about, like what ablation would they care about, and really sort of preempt that and add it into the appendix if you don't have enough space or time to add it to the main paper. And again, yes, define the baseline clearly and show how you improved upon that. So to give you an example, for the Sailor V paper, we showed that compared to essentially just looking at the single modality visual stream, adding a multimodal version, which was one of our contributions, improved significantly on clustering performance. And then adding other contributions such as non-uniform clustering and adding decorrelated heads improves upon the basic Sailor baseline on video data sets across all the clustering metrics that we considered. Similarly, with for trajectory attention, we ablated compared to like the baseline of just vanilla attention across space and time, as well as concurrent contributions from Facebook, where they did divided space and time attention. And we showed how essentially our new attention mechanism improved upon action classification performance on the 2 standard data sets, Kinetics 400 and something B2. And we also updated the different choices we made with our trajectory attention to show that we comprehend this is our knowledge, the best configuration, and this improves upon baselines in the literature. Another important part of the results section is to compare to the state of the art, and showing competitive performance compared to the state of the art just never hurts your paper. It might not be enough to get it in, but it always makes your submission at least competitive. And so I always suggest showing comparisons across a number of data sets, not just say 1 or 2. So in this case, on the Sailor V paper, we showed how we compared favorably to the state of the art across 4 audiovisual data sets. And similarly with the trajectory attention paper, we showed it across 4 action recognition data sets. And then also, and I think another thing to highlight is that there might be some sort of standard metrics that you might compare on, such as accuracy or NMI for clustering, but really thinking about other sort of dimensions that your approach might be better at, that can highlight other dimensions where your approach is favorable, whether that's its memory efficiency, its speed, or its flops. And so structure your table to highlight these other I would say, non-accuracy or non-sort of standard metrics-based comparisons or metrics. Qualitative figures. These add, I think, a lot to your paper. It complements your quantitative results by visually showing what your model is doing. So in the case of our clustering paper, it was able to automatically cluster videos into splashing water or slot machine or tapping guitar. And we could show to the reviewers like our model is actually doing what we're sort of proposing or what we're sort of arguing for. And it adds another sort of evidence that your approach is doing what it's supposed to be doing. And honestly, people love looking at figures. Like it's and for you as well, it adds space. It cuts down some of the pages that you'd have to write for your main paper. So I'm a big fan of qualitative figures. They're great. Reviewers love it, and I would always suggest adding one of these to really highlight what your method is doing, and it really complements your quantitative results really well. These are some extra practical tips that I've found useful. One is choose your venue wisely. To give you every conference is different and they value very different things. Some may be more theory-based, some may be more applied. In the case of ICML versus WACV, some might preference really pushing state of the art, which CVPR has traditionally fallen in that bucket, or some might be more domain specific versus domain agnostic. So NeurIPS accepts a broad range of research across different domains and literature, while more domain-specific conferences like ICAS, which is a speech-based conference, really only accepts papers about speech. So we're really thinking about what venue would appreciate your work is so important. And to give you a personal example, like one of my first paper for my PhD, it's a very much computer vision focused paper, and we were able to push state-of-the-art results on self-supervised video representation learning. And a lot of our impact was showing that, like, with self-supervised learning, we can push the numbers compared to, say, supervised pre-training. And so it was very much a numbers-heavy, state-of-the-art sort of paper, but we just couldn't submit it to any computer vision conferences until this year because due to either conflicts with like my supervisor being on the program committee or not getting back results in time to submit for CVPR. And so we honestly couldn't get into a conference until this year when we could have submitted to a more computer vision focused conference, which was ICCV. And so for me, I think thinking about, so it might be frustrating when your paper might not be getting into conferences, but it might just be that you're not thinking about your venue wisely enough. And the reviewers that you're getting cannot really appreciate your work. Another practical tip is honestly maintain experiment logs. This was something I was really bad at the beginning of the PhD. I would have run commands in like Apple Notes or in Google Docs, and it's just really hard to really sort of compare hyperparameters, compare results, where I saved checkpoints, and honestly, it became a whole mess. And this was something I gradually improved on during the PhD. And being able to maintain a really good experiment log is super helpful for a number of reasons. One is that it's very helpful for rebuttals in case you have to, in case that a reviewer might ask for any additional experiment, which you may have already done already. And so being able to easily get those checkpoints or those results and find that in the experiment log is super important. Then also, if you're really trying to push state of the art, an experiment log allows you to detect patterns on what types of hyperparameters are really pushing numbers forward and can then help you isolate or sort of iterate quicker because you can then focus on specific parts more. And then for reproducibility, like the field cares about reproducibility. This is an important thing. And so having these checkpoints, the hyperparameters saved, is just makes open sourcing code and reproducibility so much easier. And there are a lot of tools like spreadsheets I used during my PhD, but they are better and open source tools for this, such as MLflow and Neptune, which I've been using at my current job. And so I think invest early in sort of really building out this experimenting logging pipeline. It would save you so much pain and stress, honestly, going forward. And the last practical tip I have is essentially to open source early. Open sourcing code, I try to do honestly soon after I submit to a deadline. I submit after a deadline, because one, if you could submit code in your submission, reviewers think it honestly a lot more legit. Like they see the code, they can look it over themselves if they require. But just generally, it adds a lot to your submission if you could add code to your submission. And then if you open source it publicly, then it adds visibility and publicity of your work, because others can build upon it. They can verify your results, and then it just helps the community in terms of reproducibility. So I'm a big fan of open sourcing your code early. And I think those in my lab who've done this have gotten a ton of GitHub stars, a lot more citations, and I think work that I wish I did that would have gotten honestly a lot more cited if I had open source the code earlier than I did. And the last part of the playbook, which I think I wanted to share my experience on, is what's next. You've crushed your PhD, you have a ton of top publications, you've got that doctor in front of your name, and you're trying to figure out what's next. And so this was all of the questions that I was facing when I had graduated maybe 3 or 4 months ago. And as honestly, we're in the most, like, AI is going to be the most important parts of society going forward. You are one of the experts in the world, and honestly, you have a ton of opportunities in front of you. And so how do you decide, like, the world is your oyster in some sense? And I think decision paralysis is something that I think we as PhD students face, particularly when we sort of wrap up this PhD. And sort of these next few slides are meant to sort of give my advice on how I navigated this question of what's next, and then hopefully it can serve as some advice for you all going forward. And so I like this slide because two of my best friends from the PhD group, Yuki and Daffy, and then we all basically took very different paths towards PhD. So Yuki is now a professor. Daffy is a research scientist at one of these big industrial labs, and then an ML engineer / scientist at a startup. And so we all walked into a bus, and these slides are about advice on how these different paths look, and then how to sort of decide between these different paths. And I came up with this post PhD job matrix that tried to sort of highlight the different sort of axes or variables which could be helpful in sort of deciding between these opportunities. So the one is industrial lab, Google, Facebook, DeepMind, the academic or tenure track, so professorship, postdoc professorship, and then maybe a startup, say a seed, Series A, or maybe even later. And the axes I consider were prestige, financial outcome, academic freedom, which is essentially how much freedom do you have to work on what you want to work on. Bureaucracy, which I think is less about the work, but essentially the sort of the loops that you'd have to go through to essentially get the work done. And so yeah, I think academic freedom, I make a distinction between bureaucracy being academic freedom being the freedom to work on whatever you want, versus a bureaucracy, the sort of loops or step you'd have to do to get your work done or published, etc. And then stability, which is essentially, do I have to worry in the next 6 months I'll be out of a job, or I'm pretty much tenured for life? And so to walk you through how I sort of thought through this, and I hope it's a little bit representative of, I think, the 3 different parts, is if you're at the industry lab, I think for prestige, so for an industry lab, I think it's not as prestigious, I think, as a professorship track. I think it's quite prestigious, but I think being a professor at the top university has probably more prestige. That is debatable, but in my experience, this is what I've seen. And then for a startup, unless it's a very well-known startup, at that point, I think it's tending not to be a startup anymore. The prestige is low. And to give you an example, like my supervisor has essentially the sort of different jobs that all of his graduated students are currently at post PhD, and he only lists people at industrial labs, Facebook, Google, and those who are professors. And so I'm not, my current position is not acknowledged on his resume, to give you an extent of the sort of prestige rise associated with startups. Financially, there is, to be honest, these industrial labs pay the most, they have the most money. And so if you're trying to maximize your financial outcome, I think in the sort of short and medium term, going to an industrial lab makes the most sense. Academic track has traditionally been the lowest, particularly as a junior faculty. I think as you grow, the salary increases, but I think even as the ceiling of a academic professorship job, it's still not as good as going to these industrial labs. And then as a startup, like I think a lot of these startups are actually paying pretty well. I think on the scale, it's probably medium. I think a lot of your payout happens if the startup does really well, which is banked into, which is just very much uncertain. And so I put it on sort of like the medium scale. Academic freedom. You do have quite a bit of academic freedom in these industrial labs, but I do think one that is getting a bit less. I'm happy to have a discussion on that. And I do think a lot of these industrial labs, they sort of high up in domains that they care about. So for Facebook, they care a lot about computer vision, because a lot of the content on their platforms are videos, photos, and then speech is playing a bigger, speech and language is playing a bigger role. So a lot of their investments are in speech and NLP. But if you're interested in stuff like causality and a lot of these other domains, like it's not as represented at, say, FIA, for example. So I do think the academic freedom is a little bit on the medium end, if I was to say. Academic tenure track, you're a professor, you set your own research agenda, you have as much freedom as you can possibly have. And so I think that's, at least for me, high on the academic freedom scale. And then a startup, like, I think there's less academic freedom in the sense that, like, you can't really just sit around and just work on whatever you feel like, because a startup mightn't survive in the next 5 or 6 months. So I think academic freedom is low, but I would make a caveat that freedom in a more broader sense being that, like, you could stretch yourself in different domains. So you don't have to just work on ML-based applications. You could work on, say, infrastructure stuff if you are interested. So you have, I think, more freedom. And I think that sort of ties into my point around bureaucracy, which is sort of like, at these industry labs, bureaucracy is quite high. They have a lot of litigation opportunities. Like, so you have to essentially, like, every paper that you publish at Facebook, you have to pass it through a review. It's a could be a convoluted process. Everything has to basically go through checks and balances before it's open source. And so you have these layers of bureaucracy before you pretty much do anything. In the academic tenure track, universities are very bureaucratic institutions, and so it follows a very similar line. Startups, honestly, there's no rules. It's a very famous book title of this new book from the Netflix founders, and it sort of encapsulates generally the atmosphere and ethos of the startup, is that there are very little rules. There's very little bureaucracy. If you think something's good and you can convince your CEO, pretty much you get to do it. And then last one is stability. At these industrial labs, for the most part, you have to really try really hard to get fired. And similarly with the academic track, once you're tenured, you have a job for life. So they're both very high on stability. For a startup, it depends. Like, honestly, there's a lot more uncertainty. Startup could fail tomorrow, run out of funding, and so stability is, I think, a little bit lower for the startups than compared to academic or industrial jobs. But I ended up learning about this a bit, and so I think what I want to communicate is that what you end up choosing is very much personal to you. And so if you think about that matrix as some sort of function that you're trying to optimize, your preferences impacts this function significantly. And we could sort of encode your preferences as sort of weights of some sort of function. And so these weights depend very heavily on your preferences and your circumstances. And so you might not optimize for stability right now. Say for me, I'm just out of my PhD program. I have no kids. I have no debt. And I could I'm not trying to optimize for stability in some sense. And so the weight I put on stability is very different to maybe someone else. And these weights can be positive or negative, meaning that like I honestly really do not care about stability as much at this stage of my life. And so that would be a negative weight for me. Some people might care more about the financial outcome. They might have to take care of their family. They might have certain other circumstances. So these weights are very personal to you. And so I suggest to everyone is do what, like, no one can define or optimize this function but you. These weights are for you to decide. But a caveat I wanted to suggest to people is that these weights or your preferences vary with time. As I said, right now I don't care about stability. Maybe in 5-10 years, if I have a family, I probably care a bit more about stability. And so thinking about how your preferences may change with time or how with changing circumstances, I think is important when you make a decision. And I think people pretty much think a bit short term, or like they make a decision at a point in time and they look for the immediate or 2 months. But I encourage others to think a little bit more medium or long term, because your preferences or your weights of this function may change significantly as time increases or as time changes. And so thinking about that as you make a decision, I think is quite important. And the last point I try to emphasize is that even the variables vary with time. And so similarly with like a professorship job, at the beginning, you're probably not making, at a junior faculty, you're probably not making insane amounts of money, but 5-10 years, if you do become a full professor, tenured track, tenured, the salary is honestly very good. And so basically each of these variables has a certain function or graph, and that changes with time. And so really think about how these variables may change with time as you sort of make this decision. For industrial or academic paths, how these variables change is more or less known. Like you can look up what is the university professor salary online, at least in the US, it's a public information. And similarly with industrial jobs, there are websites available such as Glassdoor or Levels, FYI, which tells you what the salary looks like if you're a level 3 or 4 when you join, if you're able to reach a level 6 or 7. So you can sort of plot this trajectory, you can plot this graph over time to look at how these variables change, particularly stuff like financial outcomes. That's just much harder for startups. There's just a lot more unknowns. A lot of your financial outcome of a startup depends honestly on its success or failure. And so because of the information asymmetry, also there's just much less information you can sort of understand these variables or these graphs. Like probably a lot of your former classmates or lab mates work at Facebook, or they work at a particular academic lab. You could just literally shoot them a message, be like, hey, how is it like there? What is my career trajectory gonna look like? You can't really do that at a startup because you might not know anyone else at the startup. And so there's a lot more information asymmetry, a lot more uncertainty. And so the values of these variables can vary a lot, and it's very startup dependent. And so how I want to end up this presentation is, what are the questions you can use to essentially make more sense, to get the right information to reduce this uncertainty when deciding a startup? Because that's what essentially I did, and I've been very happy with my decision so far. So the questions I would suggest everyone to answer when joining a startup is, does the mission excite you? I think this is probably one of the best parts about joining a startup, is that usually a startup is trying to do something new, trying to change, make a difference. And if there's no better way to spend your time than to work on a mission or on problem that really get you excited, that make you wake up in the morning and want it to just work forever. And so really think about, does this mission excite you? And if it does, that's probably a good indication that this is something that you should be looking to consider. What is the stage of the startup? Like, I joined a Series A startup, and the sort of risk dynamics is very different to say a seed stage startup versus say a late stage or Series B plus startup. And to think about what level of risk are you comfortable with, and what kind of impact are you trying to make? Like at a seed or Series A startup, the amount of impact you can have is so much greater. Like the company is still in sort of embryonic stages, and you can have a really big impact on its mission, on its culture, on the products that it builds, the users that it targets. And so really think about what stage of startups really gets you excited. Third, do you like the people that you're going to be working with? Like you're going to be spending so much time with these people. It's a small company, it's probably less, but it's probably like a very few number of employees. So really think about, do you like the people that you're going to be working with? Are you going to enjoy your time with them? Are you going to learn from these people? And so this is probably, those three are probably like the three most important things I would consider as you join a startup. Others which are also quite important. What is going to be your role at the beginning, and how is that going to change? Are you going to be doing more applied work or more research work? Do you like that? Do you not? And really think about those questions. What are your financial goals? Depending on what your financial goals are in the short and medium term, a startup honestly may make sense because they pay you quite well, maybe not as much as an industrial job, but in the outcome that it goes really well, payouts honestly much better than say if you were to work at these big companies. And so thinking about what are your financial goals in the short to medium term, and how does the startup's current trajectory fit into those goals? Something I touched on before, are you okay with doing more applied work or work outside of your domain of expertise? At a startup, you pretty much do everything. Are you okay with that? Do you enjoy that? I do. As it's been one of the most enriching part of joining a startup for me. Who are the investors? If we think about correlation variables, the investors play a big part in how successful a company is. To be honest, they connect you with the right people, and they help you a lot with recruiting, just brand. And so think really carefully about who are the investors and whether they can really make an impact on sort of the trajectory of the startup. And then, as I've touched before in sort of these slides, like what is your risk appetite? Like, are you okay with the startup failing in 6 or 12 months? Does it not matter? Like, is that exciting to you? Yeah, these are all questions that you got to answer. And to end, yes, this playbook hopefully allows, the end of the playbook I want is essentially help you build the right village to make you successful during your PhD. Follow the checklist, the 6 C's to have a competitive paper submission. And then yes, only you can decide what you want to do after your PhD. That function that you're trying to maximize is yours. It's not anyone else's. And with that, I thank you.